This is presentation 2 in our sign language translation project. And basically, sign language is a visual-based natural language that the deaf use as a means of communication. So since most hearing people, should I say, are unable to understand said sign language, we're trying to solve this problem and then bridge that gap. We're also trying to avail more opportunities to the hard of hearing community, because if we are able to understand them, then I think this will open up different opportunities for them. So we were tasked with finding a data set that is appropriate for our project, and how does it solve the problem. So the data set basically is contributing to developing a technology that reduces the communication problems of speech between the hearing and the hearing impaired persons. So it's also supposed to allow for real-time translation of sign language to text. What did we consider before selecting the data set? We considered a number of factors, one of them being the practicality of the data set. How practical is it? So for this, we looked at the usability, because we got this data set from Kaggle. So we were comparing usabilities on a scale of 10. They were rated. So we looked for one with a high usability. Then we were checking for the accuracy. Then the contents within, are they videos, are they images? This was also considered. The training and testing data that was availed. Some of these data sets only went through the training process, but they didn't actually test the data that they had collected. So then how big is the data set, the size? We all know that a good model is basically, what defines a model is the amount of, a model is as good as the amount of data it has. So we considered the size, then also the feedback from other users, the upvotes and the comments, and how recently was this data set updated. A few important features in this data set that the AI model is going to use is the hand that was used. For example, when we are signing, we usually use our right hand. Then we considered the background of the pictures. Is it a black background? Is it a white background? Will we be able to use the data set if the background we have differs from the background in the data set? Then the angles in which the images were captured. So the better data set had images captured in all the various different angles. So Bayesian theorem is basically a method of calculating the conditional probabilities. So it's describing how likely an occurrence is to happen based on evidence that could or could not be related to it. So it's just describing the probability of an event based on the conditions that are either or not related to it. How useful is the Bayesian theorem? It provides a way of combining the data you had before, the information you had before with the current data. So all the prior information you collected and then the data so that you can make a solid decision. And it also provides a method to think about the relationship between the data set and the probability. Then another concept is the naive Bayes theory. So naive Bayes, it's an algorithm that utilizes Bayes' rule together with a strong assumption that the attributes are conditionally independent given the class. So this technique assumes independence among all the predictors. So it's mainly used in text classification, and it's based on Bayes' theorem, as I said. Advantages of this: it's simple to use, it's easy to implement, it doesn't require as much training data, yet it's used for large volumes of data because it's best for large volumes of data. Then it handles both continuous and discrete data and is highly scalable and has a variety of data points. Then Bayesian networks. Bayesian networks are basically a model under probability still. They are a graphical model that represent the different variable sets and all their corresponding conditional dependencies. So they allow for immediate and direct knowledge, expert knowledge input. Yeah, so you're relating all variable sets to their conditional dependencies. What are the advantages of these networks is they solve all problems because they're dependent on very many variables. They solve probabilistic problems. Then the networks predict and derive relationships between multiple variables and events. The difference between Bayesian theorem and naive Bayes is, we said, naive Bayes assumes conditional independence, which the Bayesian theorem doesn't. Then naive Bayes is a supervised learning algorithm, unlike the Bayesian theorem. And it's faster, much faster than the Bayesian theorem because it deals with large data sets. So the differences between naive Bayes and Bayesian networks, basically the difference is Bayesian networks model relationships between features in a general way, while naive Bayes assumes that all the features are independent of each other. And I think that's it for today's presentation.